Out there, beyond the edge of the worlds we know, something impossible was seen. A traveler. Not a comet like the ones we have catalogued for centuries. Not an asteroid orbiting quietly in the belt between Mars and Jupiter, but a stranger with no clear home. On July 1st, 2025, astronomers confirmed what their instruments were telling them. An object was moving through the solar system at a speed and on a path that made one thing undeniable. It did not belong here. Its name was given in the formal way astronomers name such things, 3I Atlas. It was the third confirmed interstellar object ever detected by humanity. And it should not exist. Imagine the solar system as a small island, lit by a single star. Around us, the planets trace their orbits like predictable tides, circling in endless repetition. Comets fall inward and outward in long, graceful arcs, carrying tails of gas and dust that we can anticipate and even celebrate. The orbits of these bodies are like footprints in the sand, regular, predictable, bound to our star. And then imagine, one quiet night, finding a set of footprints that came from the sea. Footprints that do not belong to anyone who lives on this island. Footprints that appear suddenly, cut across the sand, and vanish back into the waves. That is what 3I Atlas represents. A messenger from the deep waters of the galaxy. A sign that beyond the borders of our world, other forces are at play. For most of human history, we had no reason to believe that fragments of other star systems could ever reach us. The solar system felt like a closed system, sealed off by the immensity of interstellar space. That changed in 2017, when telescopes detected something extraordinary. A long, tumbling object on a hyperbolic path that could only mean one thing. It was not from here. It was called Oumuamua, a scout in Hawaiian. 2 years later, in 2019, another interstellar traveler was discovered, Comet Borisov, glowing with a familiar tail but carrying chemistry that hinted at its alien birthplace. And then, after years of quiet, came 2025. The third, 3I Atlas. In less than a decade, humanity had gone from never seeing such an object to detecting 3. The message was clear. The galaxy is not empty. It is alive with travelers. Astronomers working with the Asteroid Terrestrial Impact Last Alert System, known as ATLAS, spotted it first. A faint dot among the stars, moving with just enough difference to raise suspicion. At first glance, it could have been a comet like any other. But as its trajectory was plotted, the numbers told a different story. It wasn't orbiting the sun. It wasn't bound to return. It was flying through, on its way from one corner of the galaxy to another. Its velocity was staggering, more than 56 kilometers per second relative to the sun. That speed is too great for capture, too great for an orbit. It was moving with the freedom of an interstellar visitor, unconstrained by the gravity that holds everything else here in place. In that moment, 3I Atlas transformed from a faint object on a telescope screen into something monumental, a shard of another solar system wandering across ours. And yet, there was something strange about it. We expected it to behave like a comet, to grow brighter in a smooth, predictable way as sunlight warmed its surface and released gases. Instead, its brightness flickered, sometimes flaring, sometimes fading. We expected its shape to be straightforward, but telescopes could not agree. Some data suggested it was elongated, like Oumuamua. Others hinted it was fractured, shedding pieces of itself as it traveled. It was both familiar and unfamiliar at once. A paradox wrapped in ice and dust. Like Oumuamua, it defied categories. Like Borisov, it carried the clear fingerprints of a comet. And yet, it was neither. It should have been easy to classify. It should have been just another comet. But it wasn't. 3I Atlas existed in the space between definitions. A reminder that nature does not obey the boxes we build for it. For astronomers, the discovery was electrifying. here was a chance to glimpse material forged beneath another sun, to study the chemistry of a world light years away without ever leaving our own. For philosophers and dreamers, the meaning was even deeper. Because 3I Atlas is not just a piece of rock and ice, it is a story of a solar system that once had its own comets and asteroids. A story of chaos where a fragment was ejected by the gravity of giant planets. A story of survival as it drifted silently for millions, perhaps billions, of years across the interstellar void. And then, against all odds, its story intersected with ours. For the briefest of moments, the journeys of two solar systems crossed, and we were here to witness it. But what does it mean, truly, to see something like this? Does it remind us how vast the galaxy is? How easily fragments of other worlds can slip into our skies without warning? Does it tell us that interstellar objects are far more common than we ever dared to imagine? Or does it whisper something even more unsettling? That what we think of as normal is only a fraction of what exists. 3I Atlas is not just data points on a chart. It is a question made visible, a riddle written in dust and ice, a reminder that the universe is still filled with surprises. So tonight, we follow its journey. We will retrace the path of 3I Atlas, from its silent arrival to the questions it forced us to ask, and to the deeper mysteries it left behind. We will place it alongside Oumuamua and Borisov, comparing their strange differences, their echoes of alien chemistry. We will explore the science of hyperbolic trajectories, of interstellar debris, of galactic migration, and finally, we will step back and reflect on the larger meaning, what these objects tell us about the galaxy we live in, and about ourselves. Because when something from another star passes this close, it is more than an astronomical event. It is a reminder that we are not isolated, that we are not alone, that we are part of a galaxy alive with motion, rich with stories brimming with mysteries, and sometimes against all odds. That galaxy sends us visitors we cannot explain. When we think of the solar system, most of us picture the planets, the glowing reds of Mars, the storms of Jupiter, the pale rings of Saturn. But orbiting in the spaces between, there is another cast of characters: comets, asteroids, fragments left over from the birth of the solar system. They are the wanderers we know, the family of small bodies bound forever to our sun. For centuries, comets were omens. Ancient cultures saw them blaze across the sky and interpreted them as signs, harbingers of disaster or symbols of great change. To early observers, they were unpredictable visitors, glowing with strange tales, appearing without warning. But science revealed their secret. Comets are icy bodies, often no larger than a mountain, made of frozen water, carbon dioxide, ammonia, methane, fragile mixtures of ice and dust. They come from the cold outer reaches of the solar system, the Kuiper belt beyond Neptune, and the Oort cloud, a vast spherical shell of trillions of icy objects thought to encircle the sun like a distant halo. When comets approach the sun, their surfaces awaken. Ice sublimates, transforming directly from solid to gas, and dust is swept away by solar wind, creating the luminous tails we see streaking across the sky. Their orbits are predictable. Some return every few decades. Some take centuries or millennia. But they follow rules. They obey gravity. Think of Halley's Comet, perhaps the most famous of all. Every 76 years, like clockwork, it reappears in the sky. Civilizations separated by centuries have witnessed it, recorded it, and known that it would return. Comets remind us that even the dramatic can be predictable. They are wanderers, yes, but they wander within a map we understand. Then there are the asteroids, rocky, metallic fragments left behind after the planets formed. Most live in the asteroid belt between Mars and Jupiter, where the gravity of the giant planet prevented a world from ever fully forming. They are quieter than comets, lacking the icy tails that make comets glow. But their story is no less important. Some are rubble piles, loose collections of rock and dust barely held together by gravity. Others are solid iron, remnants of shattered planetary cores. A few, like the near-Earth asteroids, cross paths with our planet, reminding us that these silent fragments can be dangerous. But dangerous or not, they too are predictable. We track them, we map their orbits, we catalogue them in databases with tens of thousands of entries. Space agencies have even sent missions to meet them. Japan's Hayabusa missions landed on asteroids and brought samples back to Earth. NASA's OSIRIS-REx mission touched the surface of Bennu, collected material, and returned it in 2023. Probes like Dawn explored Vesta and Ceres, revealing them to be worlds unto themselves. Asteroids are fragments of our own history, fossils of the solar system's formation. They tell us how planets were built, and in all their variety, they follow the rules. They are bound to the sun. They obey gravity. Their stories, while complex, are written in familiar language. Together, comets and asteroids form the background of our cosmic neighborhood. They are our regulars, the wanderers whose orbits we can predict, the fragments we can catalogue and revisit. Imagine standing on a shoreline, watching the tides. The waves come and go in cycles. The moon pulls the water in rhythms we can measure, predict, even use to guide our lives. That is what comets and asteroids are to astronomy. The tides of our solar system. They move in cycles. They can surprise us, yes, but within limits we can understand. Even when a new comet is discovered, we know how to place it in the grand design. Even when an asteroid crosses Earth's orbit, we can calculate its trajectory decades into the future. They are not strangers. They are family. They belong here. This familiarity is more than scientific. It is psychological. For thousands of years, humans looked up at the night sky in fear and awe. The heavens seemed unpredictable, filled with signs and wonders beyond our control. But as science advanced, we learned to measure, to calculate, to predict. Astronomy became a way of turning chaos into order, of turning fear into understanding, of transforming mysterious streaks in the sky into objects we could name, classify, and even visit. There is comfort in that, to know that the universe obeys laws, to know that comets return on schedule, to know that asteroids orbit where we expect them to. It creates the sense that the solar system is a closed book. Complicated, yes, but ultimately knowable. So when astronomers see a faint new dot moving against the stars, the instinct is to classify it. Is it a comet? Then it should brighten as it nears the sun, its icy surface shedding gas. Is it an asteroid? Then it should remain relatively stable, reflecting sunlight without sudden flares. Every new discovery should fall into one of these categories. Every object should fit the model. Because in our experience, this is how the solar system works. Comets and asteroids are the wanderers we know. They have rules, they belong. And that is why the arrival of 3I Atlas was so shocking. It looked, at first, like it belonged to this familiar family. A faint object, possibly a comet. Another icy wanderer from the distant Oort cloud. But it wasn't. Its path was wrong. Its speed was wrong. Its behavior was wrong. And that wrongness forced us to confront something we rarely face. That our model of the solar system is not complete. That there are visitors who do not fit. That sometimes the universe delivers a reminder that the familiar is only part of the story. 3I Atlas looked like a comet, but it was not. It was something stranger. Something from elsewhere. And in that single realization, the comfort of the familiar was shattered. For months, astronomers had been doing what they always do, scanning the skies for faint moving points of light, the Asteroid Terrestrial Impact Last Alert System, better known as ATLAS, was built for exactly this purpose. Its telescopes in Hawaii and Chile sweep the heavens every night, searching for objects that could one day collide with Earth. It is humanity's early warning system, a network designed to spot cosmic threats before they strike. On July 1st, 2025, Atlas found something. A faint dot, a quiet speck against the endless backdrop of stars. At first, nothing about it seemed unusual. Just another candidate. Just another small body to be measured, catalogued, and slotted into the growing database of solar system wanderers. But then, the trajectory was calculated, and everything changed. Normally, when astronomers detect a new object, they plot its orbit. Within hours or days, they can tell whether it belongs to the family of comets or asteroids tied to our sun. The math is straightforward. Measure its position, measure its movement, and gravity tells the rest of the story. But this object didn't follow the story. Its orbit wasn't an ellipse. It didn't curve neatly around the sun. It wasn't closed. Instead, it followed a hyperbolic trajectory, an open-ended curve. That shape meant something extraordinary. The object was not bound to the sun at all. It was just passing through. Like a ship crossing an ocean, it had entered our solar system on one side and would leave it on the other, never to return. The realization spread quickly among astronomers. This was not a comet from the Oort cloud. This was not an asteroid nudged inward by Jupiter. This was something else entirely. It was interstellar. The numbers sealed the truth. The object was moving at more than 56 kilometers per second relative to the sun. That's over 125,000 miles per hour. Too fast to be captured. Too fast to belong. Too fast for any solar system origin. For comparison, most comets and asteroids move at 10 to 30 kilometers per second in their orbits. Even the fastest bound objects, those diving close to the sun, remain within gravitational control. But this was escape velocity incarnate. No comet born of the Oort cloud could achieve such speed on its own. No gravitational encounter within the solar system could account for it. The only explanation was that it had been born in another star system, ejected long ago, and had spent millions of years drifting between the stars before entering ours. As the data solidified, the object was officially designated 3I/ATLAS. The 3I marks it as the third confirmed interstellar object ever detected by humanity. The ATLAS honors the survey system that discovered it, but spoken aloud, astronomers and science communicators gave it a more dramatic identity. 3I Atlas, a name that felt almost mythic, as though the heavens themselves had reached out with a puzzle written in stone and ice. This was not the first time humanity had faced such a revelation. In 2017, when Oumuamua was detected, the astronomical world was shaken. Its shape appeared elongated, like a cosmic shard, tumbling end over end. It showed no cometary tail, no visible outgassing, and yet it accelerated slightly as if something unseen was pushing it. Its very existence challenged our categories. In 2019, Comet Borisov followed, behaving more like the comets we know, glowing with gas and dust, sporting a beautiful tail, but carrying chemistry that suggested an alien birthplace. And now, in 2025, 3I Atlas had arrived. At first, it seemed more like Borisov, a comet, faint but active, shedding gas as it neared the sun. But then, the inconsistencies emerged. Its brightness was erratic, sometimes flaring more than models predicted, sometimes fading unexpectedly. It didn't follow the script. It was both familiar and alien at once, something that seemed to hover in the space between Oumuamua and Borisov. One of the first oddities scientists noticed was its light curve, the way its brightness changed over time. Normal comets grow brighter smoothly as they approach the sun, then dim again as they retreat. But 3I Atlas behaved differently. Its brightness surged and dipped irregularly, suggesting violent activity on its surface. Some astronomers proposed that it was fragmenting, shedding pieces into space. Others suggested its composition was exotic, filled with volatile ices like carbon monoxide that vaporize at far colder temperatures than water ice. If true, this meant that 3I Atlas carried chemistry rarely, if ever, seen in comets born in our system. It was a chemical fingerprint of another star. As telescopes tried to image it more closely, another mystery emerged: its shape. With objects this faint and distant, astronomers often infer shape from how the brightness changes as the object rotates. A smooth, round body reflects light consistently. An elongated or irregular body reflects it in pulses, like a lighthouse beam. 3I Atlas didn't give clear answers. Its light curve suggested irregularity, but not enough to pin down. Was it elongated like Oumuamua? Was it fractured into multiple pieces? Or was it cloaked in dust that obscured its true shape? No telescope could say for certain. And so, the image of 3I Atlas remained frustratingly out of focus. A faint blur of light, defined more by mystery than clarity. The discovery rippled through the scientific community. On one hand, it was exhilarating. A chance to study matter forged around another star. On the other, it was unsettling. If interstellar visitors were this common, 3 in less than a decade, how many had passed through undetected before our telescopes were ready? It raised urgent questions. How often do interstellar objects enter the solar system? Could some of them pose risks if they pass too close to Earth? Could missions one day be launched to intercept and study them up close? For astronomers, it was a paradigm shift. For humanity, it was a reminder that the solar system is not a closed island, that the galaxy is alive with motion, that fragments of other worlds can and do wash up on our shores. But beyond the science, there was something deeper. For centuries, we had comforted ourselves with the idea that comets and asteroids were part of our family, bound to our star, explainable within our models. 3I Atlas broke that comfort. It looked familiar enough to deceive us. It behaved just strangely enough to unsettle us. It forced us to admit that not everything in the sky fits our categories. It was a twist in the story of astronomy itself, a reminder that nature does not conform to our expectations, and that the universe always has more chapters than the ones we've written. And so, we come to the heart of the paradox. By every rule of classification, 3I Atlas should have been easy to explain. A comet brightening in the sun's heat. A faint blur following a path we could map. But it wasn't. Its orbit was wrong. Its velocity was wrong. Its brightness was wrong. Its shape was uncertain. It was a visitor that wore the mask of familiarity, only to rip that mask away the closer we looked. It should not exist. And yet, it does. The discovery of 3I Atlas opened a door. But what lay beyond that door was not clarity. It was a maze. Every time astronomers thought they had an explanation, another twist appeared. Every time the data seemed to settle, the object refused to conform. 3I Atlas was not just a visitor. It was a puzzle. Let us begin with the one fact that is undeniable: its orbit. Unlike the comets and asteroids tied to the Sun, 3I Atlas moved on a hyperbolic path. Its eccentricity, the measure of how much an orbit deviates from a perfect circle, was greater than 1. That alone confirmed its interstellar origin. It was born elsewhere. But elsewhere is a vague word. What does it mean in practical terms? Imagine a young solar system in chaos. Giant planets forming, their gravity slingshotting smaller objects outward. Comets colliding, scattering, being thrown into interstellar space. Some are flung inward toward their star, where they perish. Others are cast outward at incredible speeds, freed forever from their home sun. 3I Atlas was almost certainly one of these exiles, born in a star system we cannot name, shaped by forces we cannot see, cast out millions, perhaps billions, of years ago. Since then, it had drifted through the galaxy, silent, cold, invisible, until chance brought it here. When astronomers study comets, chemistry is everything. The gases they release tell us about the materials frozen into their ices. With Borisov, the second interstellar object, this was relatively straightforward. Telescopes detected carbon monoxide and water, familiar but in unusual proportions. It was alien chemistry, but recognizable. With 3I Atlas, the chemistry was harder to pin down. Its brightness was faint, its coma unstable. But the signs suggested exotic ices, substances that vaporize at lower temperatures than the water ice common in solar system comets. Carbon monoxide, carbon dioxide, perhaps even nitrogen ices. If confirmed, this would mean 3I Atlas carried a fingerprint of its birthplace, a star system where different ices condensed, where the environment was unlike ours. Think of it as a message in a bottle, not written in ink, but in chemistry. One of the most striking features of 3I Atlas was its instability. Unlike Borisov, which glowed with a consistent tail, or Oumuamua, which showed no tail at all, 3I Atlas flickered. Some nights it brightened dramatically, as though a burst of gas had erupted from beneath its surface. Other nights it dimmed, fading almost to invisibility. This led to one haunting possibility, that it was breaking apart. Fragmentation is common in comets. As they near the Sun, internal pressure builds. Jets of gas carve fissures. Some simply crack. Others shatter entirely, leaving trails of fragments. 3I Atlas may have been in the process of disintegration as it passed through the solar system. If true, this would explain the erratic brightness. Large chunks could have separated, exposing fresh ice that sublimated in bursts. It would also explain why telescopes struggled to determine its shape, if it was not one object, but many fragments drifting close together. Oumuamua, the first interstellar object, remains one of the greatest astronomical mysteries of our time. It showed no cometary tail. It appeared elongated, like a shard or even a pancake. It accelerated slightly as it moved away from the Sun, without visible outgassing. Some suggested exotic ices, invisible to telescopes. Others proposed hydrogen ice that sublimated too quickly to detect. A few speculated wildly, could it even be artificial? 3I Atlas carried echoes of Oumuamua's mystery, its irregular brightness, its uncertain shape, its refusal to behave like a normal comet. But unlike Oumuamua, it did show signs of outgassing, however erratic. It was not inert. It was active, just not in a way that made sense. In this way, 3I Atlas stood between the extremes, more comet-like than Oumuamua, less consistent than Borisov, a hybrid mystery. Borisov was the normal interstellar comet, if such a phrase can be used. It looked like a comet. It behaved like a comet. Its chemistry was alien, but its physics were familiar. 3I Atlas should have been Borisov's twin. Instead, it became its foil. Where Borisov glowed steadily, Atlas flickered. Where Borisov gave clear chemical signatures, Atlas whispered uncertainty. Where Borisov was easy to categorize, Atlas resisted every label. The comparison made it clear. Interstellar objects are not a single class. They are diverse, they are unpredictable. Each one tells a different story about its home system. To truly grasp the significance of 3I Atlas, we need to think in magnitudes. Astronomers estimate that for every star in the galaxy, there may be trillions of small bodies, comets, asteroids, fragments. Many of these are ejected into interstellar space during planetary formation. That means the Milky Way may be filled with more wandering objects than stars themselves. 3I Atlas is not unique. It is one of countless drifters. But what is unique is that we saw it, that our telescopes caught it, that, for the first time in history, humanity is beginning to sample the debris of other worlds. the discovery of interstellar objects raises a tantalizing possibility: interception. What if, instead of merely observing these visitors, we could send spacecraft to meet them? Oumuamua moved too quickly, Borisov too. By the time they were discovered, it was already too late to launch missions. But scientists are now designing concepts like interstellar interceptors, spacecraft on standby, waiting in space, ready to be deployed the moment another interstellar object is detected. Imagine it, a probe racing outward, catching up to one of these visitors, sampling its dust directly, perhaps even returning material to Earth. It would be like holding a piece of another solar system in our hands. 3I Atlas may be gone soon, but its discovery strengthens the case for these missions. Each visitor is fleeting, each is unique, and the next one could be even stranger. The implications of 3I Atlas ripple far beyond astronomy. If interstellar objects are common, then planetary systems everywhere are connected, not by communication, not by travel, but by debris. Fragments of one star system drift into another. Material is exchanged. Over billions of years, the galaxy becomes a web of shared matter. That raises provocative questions. Could interstellar comets carry the building blocks of life, seeding them across the galaxy? Could fragments from one planet eventually land on another, sharing chemistry, sharing potential? Could Earth itself be built, in part, from debris born around other stars? 3I Atlas does not answer these questions, but it forces us to ask them. In the end, 3I Atlas remains unresolved. Its chemistry is uncertain. Its shape is unclear. Its brightness is erratic. It is a riddle we glimpsed for only a short time before it continued its journey into the dark. But in that short time, it expanded our sense of the possible. It reminded us that the universe is not tidy, that not every discovery fits the model, that sometimes the cosmos sends us puzzles with missing pieces. 3I Atlas was not just a comet. It was a paradox, a contradiction, a visitor that should not exist, yet does. For astronomers, the discovery of 3I Atlas was a triumph of observation and science. But for humanity, it is something more. It is a mirror. Because what do we see when we look at an object born around another star? We see possibility, we see connection, and we see ourselves against the canvas of something far larger. Consider what 3I Atlas truly is, a piece of another solar system. Its ices froze under the light of a different sun. Its dust settled in the gravity of worlds we will never see. Its chemistry was written in an environment utterly foreign to ours. And yet, here it was, visible through our telescopes, crossing our skies. This means that our solar system is not isolated. The galaxy is porous. Fragments drift from one star to another like pollen on the wind. If matter can cross the gulf between stars, what else might it carry? Perhaps the building blocks of life, organic molecules frozen in cometary ice. Perhaps complex chemistry, forged in conditions our system never experienced. Perhaps even material ejected from planets, carrying echoes of alien worlds. 3I Atlas reminds us that we are not separate from the galaxy. We are embedded within it. We are connected to it. One way to imagine this is as an ocean. Stars are islands scattered across the sea. Each one has its shores, its planets, its comets, its asteroids. Life, if it exists, grows along those shores. But in every ocean, debris drifts. Wood, seeds, fragments of ships, bottles tossed into the waves. And sometimes, one island's debris washes up on another. 3I Atlas is driftwood, a shard from another shore. Evidence that the galaxy is not a collection of isolated islands, but an ocean alive with exchange. We often imagine interstellar travel as something that requires ships and engines, but in truth, the galaxy already travels, it already moves, it already carries fragments across its currents. Three-Eye Atlas is proof of that. This idea touches on one of the oldest and boldest scientific speculations, panspermia. The theory that life, or at least the ingredients of life, can spread across the galaxy, hitching rides on comets and asteroids. Could life on Earth have begun this way? Could the organic molecules essential for biology have arrived not from Earth itself, but from a comet carrying chemistry born around another star? Three-Eye Atlas cannot answer that, but it forces us to consider the possibility. If interstellar objects are this common, if the galaxy truly is filled with drifters, then the exchange of chemistry is not rare, it is inevitable. And if chemistry is shared, then perhaps life itself is not unique. Perhaps it is seeded across the galaxy, waiting for the right environment to awaken. Three-Eye Atlas, silent and cold, may not carry life, but it carries the suggestion of a universe where life is possible in many places. But let's bring this closer to us. What does it mean, emotionally, to stand on Earth and realize that a fragment of another star system is passing overhead? It means humility. It means wonder. It means recognizing that our story is part of something much bigger. For most of human history, we thought of the stars as distant, unreachable, eternal. The heavens were separate from us. We lived here. They existed there. Now, in the span of less than a decade, we have seen 3 objects from other stars pass directly through our neighborhood. The heavens are not closed. The heavens visit us. This realization changes our place in the universe. We are not observers of a distant galaxy. We are participants in it. And yet, there is something bittersweet about Three-Eye Atlas. It came and it went. A brief flicker of mystery. A momentary guest. By the time we understood what it was already on its way out, fleeing back into interstellar space. We could not hold on to it. We could not study it in detail. We could only watch as it passed, like a shooting star, whose meaning we could barely grasp. This fragility mirrors life itself. Moments come and go. Opportunities appear and vanish. The universe is not built to linger. It is built to move. Three-Eye Atlas is a cosmic reminder of that truth, but it is also a challenge. If interstellar visitors are common, then the next one may come soon. And perhaps, next time, we will be ready. We could build missions that wait in space, prepared to intercept. We could capture samples, analyze chemistry, and bring the story of another star system directly into our laboratories. We could transform these fleeting encounters into tangible discoveries. Three-Eye Atlas is a reminder that we live in a time of possibility, that the universe is offering us gifts, that the only question is whether we are prepared to accept them. And finally, there is the deeper reflection. When we gaze at Three-Eye Atlas, we are looking at something that has traveled for millions of years, something that was ejected long before humans existed, long before Earth's continents were in their present shape, long before mammals walked the land. It is ancient beyond imagination. And yet, in 2025, its path crossed ours. The odds of this are staggering. The meaning is humbling. It is a reminder that the universe is not static, that time and motion weave together in ways we cannot predict, that fragments of other worlds will sometimes, against all odds, come into our sky. Three-Eye Atlas is more than a comet. It is a story of connection, a symbol of a galaxy alive with motion, a reminder that we are part of something larger. In the beginning, we asked a simple question. What was this strange object racing through our solar system, breaking every rule we thought we knew? We called it Three-Eye Atlas, the third interstellar visitor ever seen by human eyes. But in truth, the name is just a label. Because what it represents is not a number or a designation. It is a story about the universe itself. Comets and asteroids, our familiar wanderers, taught us that the solar system is a family, bound together by gravity, moving in predictable cycles. 3-Eye Atlas taught us that the family is larger than we imagined, that there are cousins we have never met, that there are visitors who arrive unannounced, stay briefly, and depart forever. It was both familiar and alien. A comet that was not quite a comet. A visitor that carried the chemistry of another star. A riddle we could not solve in the time it gave us. And that, perhaps, is the point. Because when we look up at the night sky, it is easy to forget scale. The stars seem fixed, eternal, distant. But 3-Eye Atlas reminds us that the galaxy is alive with motion. Stars orbit the galactic center. Planets dance around their suns. Fragments are cast outward, flung across light years, to wander endlessly. Every so often, one of those wanderers crosses our path. Not because we are special, but because we are part of the same galaxy. Because we share the same cosmic ocean. That reminder of scale is humbling. It tells us that we are small, just one planet, orbiting one star in a sea of billions. And yet, it also tells us that we are connected, that our story is woven into the larger story of the Milky Way. Soon, 3-Eye Atlas will be gone. Already, its path carries it outward, beyond the reach of most telescopes, back into the dark between stars. It will not return. Its story, in our sky, is over. But in its brief passage, it gave us something profound, a reminder that the universe is not finished surprising us, that there are mysteries still drifting toward us, that we live in a galaxy that sends us visitors from beyond the horizon. The real question is not whether interstellar objects exist. We now know they do. The real question is, what will we do when the next one arrives? Will we watch from afar, letting it slip away? Or will we be ready to send missions, ready to study, ready to hold in our hands a fragment of another world? 3-Eye Atlas challenges us to be prepared, to keep searching, to recognize that these brief encounters are opportunities that may never come again. But even beyond science, there is the human thread. For every person who looked up at the night sky in 2025, knowing that a fragment from another star system was there, visible, real, that knowledge left an imprint. It stirred wonder. It stirred humility. It stirred the age-old question, what else is out there? That question has driven us from the caves to the telescopes, from the telescopes to the spacecraft, and from Earth itself to the edge of the solar system. 3-Eye Atlas is not just a comet. It is a spark to keep asking that question. And so we return to where we began. Out there, beyond the edge of our familiar planets, something impossible was seen. A traveler. Not a comet like the ones we know. Not an asteroid we could easily classify. But a stranger with no clear home. Its name was 3-Eye Atlas, the third of its kind. A visitor from the stars. It should not exist. And yet, it does. And in that existence lies the greatest reminder of all, that the universe is vast, that it is full of motion, that we are not isolated, that we are part of something greater. And that sometimes, when the timing is just right, the universe sends us a gift. And if you made it this far, thank you for joining us on this journey. Make sure to like and subscribe, and tell us what you think in the comments below. Your thoughts and curiosity help guide where we travel next. We hope to see you again on our next journey.